In this video, we're going to identify elements that get oxidized and elements that get reduced in chemical reactions. We're still going to be using the information we have on page 90 and 91 in our notebook. We're going to go through these particular reactions. I am going to jot down here that oxidation, which is loss of electrons, things get more positive, and for reduction, elements get more negative. You might want to add that to your notebook page. All right, let's first take a look at synthesis. So here's a synthesis reaction. All right, so we have A plus B yields AB. And the example is copper plus oxygen yield copper oxide. We don't know what copper that is, though. We're going to have to figure that out. So I'm just writing this down. Reduction is more negative. Okay. I'm going to have this off to the side. Right there is good. All right, we're going to use this little piece of paper to figure this stuff out. And copper here is in its elemental form, therefore it gets an oxidation number of 0. I'm going to write the oxidation numbers up here at the top. Here's diatomic oxygen. But it is in its elemental form because we don't find oxygen any other way. Therefore, this also gets a 0 for an oxidation number. And, sorry, distracted. All right, here we have copper oxide. And it's a neutral compound because there are no charges there, right? It's a neutral compound, so the sum of the oxidation numbers or ions in the neutral compound is 0. The sum is 0. So this whole thing is 0. And I'm putting the 0 down here because I want to get the oxidation numbers of the individual atoms. This is an ionic compound. It's made out of a metal and a non-metal, so I'm going to split it in half. So there we go. Now oxygen is in group 6A. All oxygen ions have a charge of -2. It's a 1-to-1 ratio, so this copper has a +2 charge. Now we're going to use this information to figure out what got oxidized and what got reduced. So if we take a look at copper, copper went from a 0 to a +2. It became more positive, so it was oxidized. Oxidation does mean loss of electrons. Reduction is gain. So because copper became more positive, it was oxidized. And oxygen went from 0 to -2. It became more negative, therefore it was reduced. And I'm going to write O here. So that is for a synthesis reaction. I'm going to move on to decomposition, which is right next door. So here's the decomp one. I'm going to keep this right here. I can move that so you can actually see it. And here we go. We have AB yields A plus B, so that is our decomposition reaction. And then we have KClO3 yields KCl plus O2. This sounds a bit more complicated. Let's start with the easy stuff first. O2 is elemental, right? So it is going to get a 0 here for an oxidation number. Potassium chloride is an ionic compound, so we are going to split that in half, just like that. And the K is group 1. It always has a +1 charge, so +1. And so therefore Cl has to be -1 because this whole thing has to equal 0. And a +1 plus a -1 is 0. Now KClO3, that's a bit more complicated because at the middle I'm going to split it. Now the K is pretty easy. The K is always in group 1, so it's +1. But this whole thing is chlorate. And let's look at this first. The sum of all the oxidation numbers of the atoms in an ionic compound is the charge on the polyatomic ion. So the sum of the oxidation numbers of these three have to equal the charge on the ion. So chlorate is right here. Chlorate, ClO3, has a charge of -1. So whatever is happening, this whole thing has to equal a -1 to balance out that +1. I'm going to just write it a little bit larger so we can actually see it. So I have K, Cl, O, and a 3. I already split it here because it's ionic. I have the +1 here, and this whole thing has to equal -1. Well, we know here that oxygen is -2 unless it is a peroxide, and this is not peroxide. So the O2, the 2- is for the oxygen. But there are 3 oxygens. Therefore, the O total is equal to -6 because I have -2 times 3 of them for a total of 6-. That means that the chlorine has to be a number so that it's added to the -6 to get -1. And that number is going to be +5. Right? Because +5 plus a -6 equals -1. Each oxygen has a -2 oxidation number. These are the numbers I want to pay attention to. I'm going to copy them here. So +5 and -2. Alright, now we're going to figure out what gets oxidized and what gets reduced. If I look at the K here and the K here, they both have a +1 charge. Nothing happened to them. Let's look at the Cl here and the Cl there. I went from a +5 to a -1. I became more negative, therefore it was reduced, and it was a gain of electrons, and that was Cl. Oxygen is a -2 charge and a 0 here. To get from -2 to 0, we became more positive, so it was oxidized. So O. The last example that we have is a single replacement reaction. A plus BC yields B plus AC. So I got magnesium plus copper oxide yields copper and magnesium oxide. Mg is in its you can't see it, is in its elemental form. Therefore, it has a 0 for an oxidation number. Copper is also in its elemental form, so I'm going to put a 0 there. And I'm going to deal with my 2 ionic compounds. I'm going to split this one here, and I'm going to split that one there. This O has to be -2, therefore this has to be +2, and this O has to be -2, so this has to be +2, because whatever this is, it equals 0, and that has to also equal 0. Now let's take a look at what got oxidized and what was reduced. Now let's take a look at magnesium. Magnesium went from a 0 to a +2. It became more positive. It must have lost electrons, so it was oxidized. So Mg. Copper is a +2 to a 0. It became more negative, so it gained electrons. And oxygen is a -2 and a -2, so nothing happened to it. Note, in all of these types of reactions, a substance was oxidized and a different substance was reduced. Double replacement reactions are usually not redox reactions, but everything else is, including combustion. So here is a screenshot of this whole page, or a full view. Sorry about that. Here you go. And this should be in your notebook on page 91.